Hey kids, it's Dr. Runs here with Objective 19. We are going to work with estimating really large numbers and really small numbers because this is our segue into scientific notation. So previously we've been talking about exponents. Now we are going to apply what we know about exponents in scientific notation. Because scientific notation uses exponents, this is a really important skill. It will bleed over into science class, and it helps you to deal with extremely large and small numbers without having to do all the writing of the long number. So we started our class with a cool video. I know it's old, it's from 1977. It's called Powers of 10. It's kind of interesting. Just to kind of get a sense of how big things and how teeny things are. I'm not going to tell you much more than that, but feel free to look that up on YouTube. It's kind of fun. So we are going to do this estimation with some things that I don't expect anyone would actually know. So we're going to talk about how far is it to get to Paris? How much milk does an average person drink every day? How fast can a semi-truck travel? How thick is this train? Like, people don't know these things, right? But when given 4 options, you can, I guess, sense which ones are the ridiculous options to use process of elimination to find the solution here. So I'll talk you through a few of them, and hopefully that'll help you. And so here we go. So our options for getting to Paris are each of these. So the exponent is increasing by 1. Now you know that anything to the power of 0 is 1. And 4 times 1 is 4. So option A is the equivalent of 4 miles. 4 miles won't get us across town, so A is not an option. 10 to the power of 1 is 10. Times 4 is 40. Well, 40 miles is like driving to Aurora. That's not going to get us to Paris. 10 squared is 100. Times 4 is 400. This is where you might need to be thinking about, what else can I compare that with? Well, if I'm driving in my car, I don't tell anybody. On the interstate, I sometimes go like 80. Sorry. I'm trying to get somewhere, people. 40 over 8 is 5. So that would be like 5 hours of driving. 5 hours of driving might not get me out of the state if I'm driving south. That's not going to get me to Europe. So in this case, 10 to the power of 3 times 4, yeah, it must be this. Something that it has been helpful for me to remember, the distance across the United States is 2,600 miles. And so when I'm making my estimations, just knowing that helps me. I'm not talking about like just math class. It helps me like in real life make estimations. It makes sense that the distance from here to Europe would be the entire width of the United States and then a little bit more. So I don't know if that helped you. So I like to be practical here. Okay, how much milk does an average American drink? Now I get that some people are lactose intolerant and don't drink any milk. Some people could have their own personal cow and they would still want more milk. This is average, right? But these are all measured in ounces, and so this is kind of hard for kids. If you think of a soda can, like a can of pop, oh, I just said pop. What is wrong with me? Soda can is 12 ounces. A water bottle, like a standard water bottle, is 16.9 ounces, so call it 17 ounces, right? So that helps you. A cup is 8 ounces. Not like a literal like cup in your cabinet, but like a measuring cup is 8 ounces. Okay, so let's see if we can work this out then. If you just had to guess about how many ounces a person drinks in a day, or like half a soda can worth, right? I mean, if you think like maybe on your cereal, maybe with your dinner, but I don't know. Most people aren't chugging a lot of milk. And in our classes, most classes decided to go with like 5 or 6 ounces a day. So let's say, because this is annually and there's 365 days in a year, let's say we go with 5 ounces a day. You might disagree. You could do like 8 or something similar. But in our case, I can multiply the long way. And did I do that right? Yeah, that's about right. So just short of 2,000 ounces. That's just my rough estimate. You could have your estimate too, right? Okay. So 10 to the power of 3 would be 1,000 times 2. Oh, wow. I have something that's already pretty close to my estimate. Now, it doesn't hurt to try the next one up and the next one down. So the 10,000 to the power of 4 would be... Did I say 10,000? I'm going to say 10 times. I was talking and doing math at the same time, and sometimes when I do that, answers come out. So I got 20,000. It's about 10 times as much, which would mean a person would drink about 50 ounces of milk in a day, and that's just gross. That's not going to happen. So the other exponents are even bigger, so I don't even need to check those. I mean, unless you really want to do math, but again, I like practical. All right. Hey, feel free to go ahead of me on this next one, and I apologize, my copy is kind of cruddy. So this is the Phoenix. It says Phoenix on here. This semi set a record in 1996, land speed record for a semi truck, and then it blew up. So it's kind of sad, right? Okay, so how fast can a semi travel per hour? Well, you know what? I'm going to guess if this is a fast semi, we're not going to have negative exponents. Because I know that anything to the power of 0 is 1, 2 times 1 is 2 miles an hour. That's not even impressive if you're a human. 10 to the power of 1 is 10, times 2 is 20 miles an hour. Also not impressive. Maybe on a bike, I don't know. 10 to the power of 2, or 10 squared, is 100. Ooh, times 2, 200 miles an hour. Now that is impressive if you're driving a semi-truck. But it's also kind of gives us a reason why it caught on fire, because I don't think semi-trucks are meant to travel that far. I mean, that fast, sorry. Okay, how thick is a strand of hair? And these are all measured in meters. We held up a meter stick in my classroom. It's about, if you hold your hands out in front of you, just a little bit wider than that, that's about a meter. Also, if you think of a football field, so if this is a football field and there's a track that goes around it, that's 400 meters. The straightaway is usually about 200 meters. So that helps me, again, in real life, not necessarily, just math, but in real life, make my judgments. So hair is small. So I'm going to think that it is really itty bitty here. So 10 to the power, I'm going to show my work here. 10 to the power of -5, we learned previously that that's the same as 1 over 10 to the 5th, which is the same as 1 over 1, 2, 3, 4, 5. That, and there's 4 of them. Okay, so that's a really teeny tiny fraction, right? I don't actually know how wide hair is. Does anyone know that? That's kind of silly, right? So because I don't actually know, maybe I should try another option. 10 to the power of 0 is 1. Anything to the power of 0 is 1 times 4. Okay, 4 meters. That's really huge. That's your hands in front of you 4 times. That's really wide for a strand of hair. So now we know that A is our option, and we don't even need to look at the bottom. Okay, so really it's kind of not so much math, but common sense and making sure that you know your units of measurement, using process of elimination, and so forth. So you only have 5 questions for your homework. This is a depth of a kiddie pool, so this is like a little pool that you'd put in your backyard, not like an in-ground or Olympic pool. The length of a lunch period, just note that it's in seconds. The age of a typical grandmother, just to make it a little bit tougher, we did it in hours rather than years because math is fun, so you'll have to convert hours to days to years and so forth. The length of a crayon. Some of my students were asking if it was Crayola or Rose Art. It has nothing to do with it, but I felt like the banter was kind of funny. A centimeter is about the width of your fingernail. I don't know if that helps. And the width of a ladybug, that's measured in inches. If it helps you with inches, an inch is about the length of one of the digits in your finger. That helps me. Maybe it helps you. Okay. All right. I hope you find this lesson to be fun. Some kids really do awesome at estimation and kind of think that this is a fun activity, or at least practical. It's good to be able to make good estimations and use some logic. So if you have any questions, though, please email me. You're not out of trouble. I actually like to help you. That's why I teach. So don't be bashful. And otherwise, I will see you in class. Thanks a bunch. Bye.